This is not a stock Elegoo Neptune 3 Pro 3D printer anymore. If prints are slow, the quality is inconsistent, and there are a constant babysitting. This video fixes that. In 3 steps, I am replacing Marlin, the basic firmware that comes with the Neptune 3 Pro, with Klipper, the new and improved firmware, and turning this printer into a remote controlled high performance machine. Let's get started. So, what exactly is Klipper? At its core, Klipper is a 3D printing firmware, just like Marlin, which most printers ship with. But here's where it gets interesting. Klipper uses a completely different architecture. With traditional firmware like Marlin, your printer's tiny control board has to do everything: motion planning, complex calculations, controlling motors, managing heaters, all at once. Klipper splits this work. It offloads all the heavy calculations, motion planning, to an external computer, usually a Raspberry Pi. Now that the printer's control board can focus on what it does best, directly controlling motors, heaters, and sensors. No more bottlenecks. And this key separation unlocks faster printer speeds, smoother motions, and more accurate results. That is Clipper. The same goal as Marlin, completely different approach. Alright, let's dive into the real difference between Clipper and Marlin. Marlin runs entirely on the printer's microcontroller, this tiny chip right here, and it does everything: motion planning, calculations, motor planning, and managing temperatures, trying to handle advanced features. But here's the real problem, especially on budget control boards, there's just not enough processing power, so you get slower calculations and a lot of advanced features. They're either limited or just not available. Clipper takes a complete different approach. It splits the workload. You add an external computer, usually a Raspberry Pi. The Pi handles all the heavy lifting, motion planning, complex math, and all those features. It sends optimized commands to the printer's board, which now only has to worry about the basics: motors, heaters, and sensors. And this is where it gets exciting, because the Pi has real processing power. Clipper unlocks features that Marlin just can't handle smoothly: higher acceleration, input shaping to eliminate ringing, pressure advance for perfect extrusion. The result, you get better performance without overloading the printer's hardware. Same print, better brain. So why do people upgrade to Clipper? Let me show you. First, speed. With Marlin, you're typically running 60, maybe 80 millimeters per second. Clipper 150, 200, even 300 millimeters per second on some setups. And here's the kicker: you're not sacrificing quality for that speed. Actually, you're improving quality. Input shaping eliminates those vibrations that cause ringing and ghosting on your prints. Pressure advance fixes extrusion issues. Your corners come out sharper instead of bulging. Third, web-based control. Mainsail, fluid, those interfaces are incredible. Start prints, upload files, tune settings, all from your phone or laptop. You're not tied to an SD card anymore. Number 4, tuning is so much easier. With Marlin, you edit code, recompile the firmware, flash it to the board, cross your fingers. Clipper, edit a config file, save, restart, done. No recompiling, no flashing, just easier. And finally, advanced features out of the box: custom macros, auto calibrations, object canceling. If one part or of all multi-object print fails, detected logs for troubleshooting. That list keeps going. That is why people upgrade. Speed, quality, control, simplicity, features, all in one package. Alright, let's be honest. Clipper isn't perfect. First, the learning curve is steep. With Marlin, you gradually learn as you go. Clipper, you dive into the deep end right away. That initial setup takes time. You're editing config files, learning new terminology and even technology. And if you make a mistake in your config, your printer won't start, or worse, it'll try to move in ways it shouldn't. Second, extra hardware. Marlin, you got a printer, you're done. Clipper needs a Raspberry Pi or similar computer. That's another $35 to $60 on top of your printer, and it's another thing that can fail. SD card corrupts, Pi dies, and now you're troubleshooting two systems instead of one. Third, it's less plug and play. Marlin is simple, less control, but easier. Clipper gives you power, but with that comes responsibility. You need to know what you're actually doing. There's no hand holding here. And finally, it's a big one. Klipper isn't necessary for everyone. If you're printing functional parts at stock speeds and your prints come out okay, fine. Marlin works, period. Klipper is for people who want to push their machines max speed, best quality, total control. Not everyone needs that, and that's completely okay. Here's the honest truth. Klipper is powerful, but it's not magic. It requires time, effort, and willingness to learn. For a lot of people, Marlin is enough, and that's okay. The question isn't, is Klipper better? The question is Klipper better for you? So, quick recap. Marlin, it's simple, it's reliable, it just works. Perfect if you are new to 3D printing. On the other hand, Klipper is fast, it's incredibly configurable, and gives you control over everything. It's for people who want to tune and optimize. Marlin is all about stability. Set it and forget it. Klipper, it's all about performance. Tweak it until it's perfect. Neither one is better. They are different tools for different purposes, and both are absolutely valid choices. So, which one is right for you? Well, that depends on what you want. Now we'll install the operating system onto the Raspberry Pi so it's ready to run Klipper and control the printer. So we need to open the Raspberry Pi imager. Inside that we need to pick our Raspberry Pi. For me it's going to be the 3B plus, so I'm going to click on it, then click next. Next we need to find the operating system that we're going to put onto our Raspberry Pi. For us it's going to be the main cell, which is under the other specific purpose. Inside that 3D printing, then main cell OS. Inside that main cell OS 2.2.2, and it's going to be 64 bits. That's the version we want to install. Since I've already installed it, I'm not going to do it, but you need to pick the SD card you want to put the Raspberry Pi image into. Next, we'll flash the Klipper firmware onto the Neptune 3 Pro's SD card to prepare the printer for its new high-performance control system. So first, we need to find the robin_nano.cur file, which is the Klipper firmware that needs to go onto the Neptune 3 Pro's SD card. Once we click on it, we need to go and download it. We can click download raw file, which means you're downloading that file, and after we've downloaded, we need to go put it onto the SD card. Now that Klipper is installed, let's configure the printer settings to ensure everything runs smoothly and accurately. Inside the GitHub repo, we have printer.cfg files. This is the main contents for the printer, and it's going to be linked down in the description. So we need to copy this file contents and go inside the dashboard, and inside the machine tab, we can see that it shows the configuration files. Inside that, we need to create one file called printer.cfg, and then we need to go and paste those contents. Inside the printer.cfg is where you paste all the contents. And then we need to save and restart. When we click save and restart, it's going to restart the dashboard, and then all the printer's settings will be saved. Next, we need to create one folder called macros. And after we create it, we need to go inside that macros folder and create another file. It's going to be pause_resume_cancel.cfg. Inside that, we need to paste pause_resume_cancel.cfg contents, which is in my GitHub repo. You can find it right here. And once you copy it, we need to go and paste in that file. And since I already pasted, we just need to save and restart. After we save and restart, what it's going to do is it's going to make the printer restart and all the settings being saved so that we can use it in our next prints. Here's the main dashboard of our setup. From here, we can control the printer, monitor its status, and manage firmware updates seamlessly. So in standby, we can see that there's files, history, and queued. Inside the temperature, we can notice that there is target values that you can set here, and that will be shown in lifetime right here in this graph. And next is webcam. Inside the webcam, you can do two things if you set up a webcam. First, it's live feed you can see. Next is 3D time-lapse, which means you can make time-lapse of your 3D models. Then console. Inside the console, you get printer statuses like starting the print, ending the print, and many more. Next is toolhead. You can control the X, Y, and Z axes using these buttons. X axis and Y axis can be controlled here, and Z offset is at 0, 0, which means it's at default value. Same for speed factor. Next is extruder. Then we have extrusion factor, pressure advance, filament length, extrusion feed rate, and smooth times. Those ones are default values. And to get the retract and extrude, you need to make the temperatures at 170 or higher so that you can make these retract and extrude be available for you. And these ones are used to make the new filament come in or old filament to come out. Next is miscellaneous. In miscellaneous, we have fan and top LED. Those ones are being off so that I'm not using it currently. And filament runout sensor is true so that I know that when filament runs out in my printer. At this point, the Elegoo Neptune 3 Pro is no longer a basic 3D printer. Control it from any device on the network, monitor prints live, and unlock performance Marlin simply can't deliver. But Klipper alone isn't the magic. In part 2, I'll show you the exact printer settings I use, the ones that dramatically improve the speed and quality without destroying reliability. If that sounds useful, subscribe, because this is where the printer actually becomes a beast.